Welcome to this lecture on user experiences in mobile games. In it, we will be looking at what makes the user experience in mobile devices different, the guidelines that have been set out for usability and playability, and then finally how to do some Unity 3D programming for Android to get this functionality happening. What makes the user experience with mobile devices so different, and how can we employ this in the games that we create? Because we no longer have the traditional keyboard and mouse. No one has answered this question any better than Apple did when they launched the iPad.
The face of the product is pretty much defined by a single piece of multi-touch glass, and that's it. There's no pointing device. There isn't even a single orientation. There's no up, there's no down, there's no right or wrong way of holding it. I don't have to change myself to fit the product. It fits me.
Mobile devices with touchscreens have dramatically changed the way that we can provide games that give very innovative user experiences. Instead of a mouse and keyboard, users can now touch the screen, draw on the screen, type on the screen, flip pages, zoom, and swivel 3D objects. The whole device itself can even be orientated to change the way that applications are interacted with. How a user experiences our game, whether it be on a desktop machine or on a mobile device, comes down to three basic characteristics. First is the usability of the game. So how does the user use the controls to interact with the game environment? And how easy and intuitive is that? Next, there's the mobility of the game. So how easily can a player enter into the game world, exit, come back in, and how does it deal with unexpected occurrences such as a power outage in the actual device? And finally, we have gameplay, which is something that has been important since the beginning of computer games. And this deals with the actual game mechanics and the story and whether they transform into different platforms. In this lecture, we will be concentrating on usability of the mobile device and the game that we create on it. It is important to realize that usability is not a single one-dimensional property of a user interface. Usability has multiple components and is traditionally associated with these 5 usability attributes: learnability, efficiency, memorability, errors, and satisfaction. After much research, Nokia came up with over 200 usability guidelines for mobile games. Here's the top 10. Make sure you have an appropriate main menu, the ability to pause and save, provide feedback, show the status, have intuitive controls, do not abuse the sound, distinctive graphics, in-game help, non-intrusive user interface, and an easy restart. Let's look at an example of these guidelines in an actual game. This is the tower defense game Starfall, available on the iPad. It has a very appropriate main menu, giving you all of the options within 1 or 2 mouse touches. The in-game help system is in the form of an almanac which goes through all of the different structures that you can build as well as the enemy units, and it gives you their hit points and their defense points. Controlling the sound is very easy, so you can set the sound effects volume and also the background music. For a mobile device game, Starfall has very distinctive graphics and they are beautifully done. The feedback system is very simple but very effective. So you can only drag your units into certain places and you get red error messages when they're in the wrong spot. The interface itself is very non-intrusive, which is what you want out of a mobile device when you don't have a lot of screen real estate. The interface is also very intuitive because it's just a simple select and drag and drop of your units. How many lives you have left and how much money you've got is always displayed at the bottom of the screen. At any time you can pause the game, and whenever you leave the game it is automatically saved. And finally, there's an easy restart option in the menu system which allows you to restart a level. As we've seen, interacting with mobile devices is very different from traditional computers, and you should think about how to add all these functions into the games that you create. So there are simple finger touches or double touches, sliding, accelerometers in devices which allows you to move them around in real space, the orientation of the device, GPS for location-based games, and also the camera. What we're going to look at now is how Unity 3D controls all of this interaction on the Nexus 1 via Android. And it does this primarily using the input.touch data structure. From this you can get the position where you're touching the screen, time that has passed, any changes in position of a touch, how many times the screen has been touched, and what phase the touch is in. Some of the functionality that is available for Unity 3D for iPhone is not yet implemented in the Android controls. The ones that we will look at today are the Get Touch Position, a delta position, which is the change in the movement of a finger on the screen, and the phase of the touch as to whether it has just started or it's ended or your finger is moving on the screen. This first lot of code, which is written in JavaScript, can be attached to the camera in Unity 3D to get the touch phases to appear on the screen of your mobile device. Very simple program. Try it yourself because I won't be demonstrating it afterwards because there's not really much to look at. So if you take this code and attach it to the camera, you'll get some GUI labels come up on screen which will show you when you've touched the screen, when you've moved your finger on the screen, and then when you've ended touching or lifted your finger up. And you can see there's 3 if statements there that set a touch string to be displayed. Now, touch began is when your finger goes down, touch ended is when your finger comes up, and touch moved is when your finger is down and moving. With the touch moved, I've also used the delta position of the finger movement to test for a larger movement before displaying the touched move, because the touched move, if you leave your finger down, it will still register very, very small movements. This next piece of code shows you how to translate a touch on the screen into a 3D position to create a new 3D object in the scene. Now all you need to do is type this into a JavaScript file, again attach it to the camera and make sure that it has a robot object. So in the update function here we're testing if the touch count is greater than 0, which means a finger has touched the screen, and that it's the first time it's touched the screen with a began touch phase. Then we take the position of that touch and run it through a screen point to ray function, which will turn your finger point from screen coordinates into world coordinates. The world coordinates are then used to instantiate a 3D object into the world. In this case we've called it robot. So every time you click on the screen with your finger, you will get a robot appear. And here is the application being demonstrated. So the robot object is the 3D Android. Up in the top corner, you can't quite read it, but that's the location of the finger touch. And I just use GUI labels to bring those up. Each robot is a rigid body, which makes it fall. This next piece of code allows you to move 3D objects around that are in the scene. So it casts a ray, and whatever it hits, if it's got a collider on it, then you're allowed to move it with your finger. The code is entirely within an update function, and it first tests if the touch count is greater than 0 and that a touch has begun. It then casts a ray from the location of the touch along the camera's line of sight. Now, using a physics raycast collision, if it hits something, it then sets focus object to be the object that you've hit. So that is the 3D object that you've put your finger on. Then when you move your finger on the screen, it uses the delta position of the finger move and applies that to the position of the 3D object, and that moves it around in 3D space. Then finally, when you stop touching the screen, the focus object becomes null, allowing you to pick up another object. So here's an example of this code running. There are two 3D androids added in the environment, and they both have box colliders, so that when the finger touches them and collides with them, it grabs hold and allows you to move them around the screen. But when you touch part of the screen when there is no 3D collider, it won't move anything. Another thing you can do with finger dragging is to use it to rotate an object. So in this next piece of code, if you attach it to the object in question, when the finger moves on the screen, that object rotates. Once again, all of this code occurs within the update function, and it tests if there's been a finger movement. It then uses the delta position of the movement to apply to the object's rotation. And in this case, it's rotating around the up axis and the forward axis of the object. So we're using a side swipe or a delta position change in X to rotate around the up vector, and we're using a up and down motion to rotate around the forward vector of the object. And this will make it appear to be movable in all directions within the 3D space, which is nice if you're wanting to create an application where people can examine objects from all different angles. This example shows a skeleton model that was taken from TurboSquid with the previous code applied to it. You can also see the feature of a double tap, which is used to zoom the camera in and out. Now, that code is not as easy to implement as it is on the iPhone, where it is a natural command. Rather, we have to write code that detects taps that are close together. This code for double touching can be added to the camera. It works by recording the time between taps on the screen. If they're close together, then it records them as a double tap. There's a threshold value which is set to 0.5 of a second, and that is used to determine whether something is a double tap or not. You can set that double tap threshold to be a smaller value or a greater value depending on your needs for the double tap. Once double tap is set to true, it stays set to true until some other program script that's attached to whatever object calls the get double tap function. So somewhere else in your application you would have code that calls get double tap. At that time it finds out if a double tap has occurred, then sets the value back to false so that it can register another double tap. The next user interaction we're going to look at that comes with mobile devices is the accelerometer. And from what it does, you might think at first that it's quite a complex set of instructions. Unity, however, has made it remarkably simple. The game of Spore Origins, which is available for the iPhone, uses the accelerometer very nicely. You can see it being demonstrated here that the acceleration and movement of the device dictates where the character will move next. Really, the only difficult thing about grasping how to use the accelerometer is getting your head around the axis direction of your device and how that translates into the 3D virtual game world. There are 8 degrees of freedom with your device that give you movement along 3 different axes. Now it's the y-axis that has 4 different phone movements to register acceleration, and here they are now. And here is some extremely simple code for moving a 3D object around when you rotate your phone. In this example, the Y acceleration is used to change the 3D object's X position, and the X acceleration is used to change the Z position. How the axes all line up will depend on the camera, so you really need to experiment. And here is a really simple application. So there's a ball on the screen, the ball is sitting on a plane, and it just has the code you saw before attached to the ball. So its position is dictated by the acceleration of the mobile device. And finally, for this lecture, we're going to look at orientation. So not only the way that you move the device, but also how it is sitting with respect to the real world. You've got portrait, portrait upside down, landscape left, landscape right, face down, and face up. And these are all values you can test for the way that the device is facing, so that when you see an application that changes its orientation when the phone changes its orientation, this is how you would program it. I apologise for the very small font, but I was trying to fit it all on the screen for you. You're using the input structure's device orientation value, and you're testing it for being a device orientation face up, face down, landscape left, etc. Now for this application, all it's doing is printing the orientation as a GUI label into the center of the screen. And now what might be a quite confusing demonstration is the camera and the phone held together, and the phone actually moved around in the real world, and you can see how the orientation is registered. If you want to see this for yourself, then I would suggest that you use the previous code and attach it to the camera and upload that to your phone and move it around. And that's all for this lecture on using Unity user interfaces for the Nexus One. I hope you found it useful and interesting.